think that's okay. Right, let's get started. Whew. All right, a quick little bit of revision. So what does the derivative represent? Yeah, it's the slope of the tangent. So if I draw a tangent here, then its slope is dy dx. What's the second derivative represent? What is it? Huh? Say again? No, what'd you say? I didn't hear you. Yeah, what's another word for that? More technical. What word do we use?
Concave.
Yeah, so what's that as an adjective? Make it an adjective?
Too difficult.
Ah, no. Convection, no. Nice try. It's also con, as in like concave. Not conduct, not convection, not current, not coordinate, or chord. Concavity. Right? Yes? Okay.
That's all right.
Yeah. Well, if it's not, I'm making it one. Right, so this tells us how concave it is, or how convex it is. Okay? So do you remember if it is positive, which shape is it?
Convex.
Convex. And if it's negative?
Concave.
Concave. Yeah? Okay. So what we're looking at now today is the meaning of the antiderivative with the limits. Now, I know a couple of you actually mentioned this yesterday, so I know some of you know this already. What is the meaning of the definite integral? What does it represent?
The area under the curve.
Area under the curve, yeah. So in this case, with the a and the b limits, how does that affect its meaning? Yeah. Okay, so here's our first definition, if you want. If you have a curve, let's call it y equals fx, and you have 2 points on it, a and b, and you want the area here. The area will be the integration from a to b, f of x dx. Okay? There are some problems with this and there's some special examples, but we'll start with an easy example. But you should all copy this into your notebook. Oh, and perhaps it's worth saying that at the moment we're only considering positive functions, okay? Got that? Yeah? Yeah, okay. So how many of you have actually seen this formula before? A handful only? Oh, no, okay, not too bad. Yeah. Okay, it's true in physics for sure, but in biology, have you done any graphs yet where it's important to know the area of the graph? No, only the height. Yeah. Yeah. There's no graph that Colin has drawn where he said, okay, now we need to get the area of this graph. No. Okay. It's very, very common in physics, and it will be in biology too, that the area has a meaning on the graph as well. But we won't worry about that just yet. Can I scroll down?
Yeah.
Yeah. So what I want to do first without using integration, without using it, I want you to give me the area here. I'm going to say y equals x. This point here is 2. So what's this point here?
2.
Okay, so without using integration and by using the power of your brain, tell me this area here. 2.
2.
So the area here is half the base. What's the base?
2.
2. And what's the height?
2.
2. So the area is at 2. Okay? So I want to show you that you get the same answer if you use integration. Actually, you know what? I'll let you integrate it because it's a very simple one. I'm telling you the area should be from 0 to 2. You put in the function here. What's the function? X. And you integrate. Okay. Calculate that. Should be 2, shouldn't it? So this is x squared over 2, 0 to 2. This is 4 over 2 minus 0, which is 2. Yeah? Okay. Let's step up the difficulty a little bit. Actually, I have a particular example here. Can I scroll down? 1 second, okay. Okie dokie, got that? Yeah, okay. So the next one. There's x, there's y, and here's my curve. Y equals x minus x squared. Okay, and I want this area here. So, before you start, or rather, what's the first thing you should do when you start?
Find A and B.
Yeah, find A and B. Yeah. Okay, I'll give you a minute to try this, and then I'll give you the answer. Let's see if you can do this. Okay, have you got answers? Yeah? Okay. So, this first, well, if you factorize here, that's x1 minus x, isn't it? So the two roots are 0 and 1. So you integrate from 0 to 1, x minus x squared dx, which becomes x squared over 2 minus x cubed over 3, 0 to 1. If I put in the 1, I get that. If I put in the 0, I'll get 0. So that's 1 over 6. I hope you got that. Okay. Yeah. Now, let me give you a trickier one now. Can I scroll down? 1 sec. You got that? Yeah. No sign mistakes? No sign mistakes? Right. The next one I have for you to try is a little bit tricky, but just like this one, you have to start by finding the roots first. Okay? Can I scroll down? Yes, no? Yes? Okay. Right. X, Y, and here's our curve. Like this. Okay, and let me give you the formula. We'll say y equals root r squared, or is a constant, okay, minus x squared. And I want this area. Yeah? Oh, right. Come back for the second class. Yeah. All right, I'll give you a minute. Try this now. Bit too tricky, isn't it? Okay, I'll stop tormenting you now. So this one here, this is something I want to do in semester 2 because it's a little bit tricky, all right? But I want you to keep it in your notebook and leave space for it because we'll come back to it, all right? But I want to see who can spot the answer without having to integrate. Forget about calculus for a moment. Oh. Yeah, go on. Good. Yeah, no, he's got it nearly. He's halfway there. It's half a circle. Yes, which is? No. A half pi r squared. Right? Yeah, okay, good. I'm glad we cleared that up. Okay, let's continue now. So please just leave some space for semester 2, okay? And we'll have a look at that when we do some further integration. But I like this example because I want to show you later that you get the same answer as this, which you all were supposed to intuitively know. Right. Yes? Yeah. All right, let's scroll down. Now, the next thing I want to have a look at is how do we calculate the area between two curves? So suppose I have one curve up here, I'll call it F, and I have one curve down here, I'll call it G, and we'll meet here, and we'll meet here. How do I get this area between the two? Hang on 1 second. Go ahead, Dasha. Yeah, so you're thinking of it like this, if I can colour it in. You get the area under F, and then the area under G, and then minus. Okay, that's fine. There's a slightly quicker way. Simultaneous will give us the A and the B. Your way works. There's just a slightly quicker way. Any ideas? You just modify your way a little bit.
Probably not even like the area down, only like on the top.
No, you do need both. Yeah. Integrate from a to b the upper function minus the lower function. Now, can you see why that's a little bit quicker? Because this way, first you minus the two functions to make one function, and you integrate one function. Whereas with your way, what are you doing? You're integrating two functions. Yeah, so you can reduce the work a little bit here. Okay. Let's have a look at an example. Can you write this formula down? Oh, and it's important that the function f is the one that's above the g.
There are other formulas. There's one with plus, one with divide. Like for other examples.
We don't worry too much about those. For the exam, it's really just area under a curve or area between curves. Yeah. Okay, you got that? Let's do an example together of this. Can I scroll down? Yeah? Okay. Scroll down? Oh, come on, hold on. Well, I'll zoom out a little bit. I want to get the area between this curve and this curve. So what will I need to do first? No. Can't. Yeah, but how do I find the limits? Simultaneous. Which method? Substitution. Yeah. Okay. So while others are writing this down, can you find the intersection points here? I don't need the y values, just the x values. Okay. Did you get the x's? Yeah, well, x plus 1 equals x squared plus 2x minus 1. So what's that? X squared plus x minus 2, is it? So you are 1 or minus 2. Yeah. Which is likely to be the upper function here? The linear or the quadratic? You have to visualize it.
Oh, no, linear.
Yeah, because it's probably something like this, isn't it? Where here is minus 2 and here is 1. Now, if we got it wrong, suppose somehow it was the quadratic on top and the linear on the bottom, it's no big deal. It just means the sign will be wrong in our answer. So we can just flip it around at the end. So it's not a big deal. Okay? Right. So let's try out our formula here. The area between them should be integrate from minus 2 to 1, x plus 1 minus x squared plus 2x minus 1. Yes? Okay. So that's integrate minus 2 to 1 minus x squared. X minus 2x is... Come on, x minus 2x. X minus 2x. Wakey, wakey. Thank you. 1 minus minus 1. 1 minus minus 1.
2.
Thank you. 2. Right. I'll give you a minute to integrate this. See what you get, please. Alex, do you have your calculator? Alex. Okay, let's have a look here. So this will be minus x cubed over 3, right? Minus x squared over 2, yes? Plus 2x, and then we have to put in our limits of 1 and minus 2. So if I put in 1, I get minus 1 over 3 minus 1 over 2 plus 2. If I put in minus 2, oh, what will that be? 8 over 3? Minus 4 over 2. Plus 4? Minus 4. Yeah? Oh, but I have it in brackets. Is this the confusion? What's wrong with this? Anything?
No.
Is it okay? Well, I want to show you something on the calculator now in a second too. So, all right. So what did you get here when you bashed this in? 9 over 2? That's different. What did you get, Kirill? 9 over 2. What'd you get? No, that's very different. Any other answers? Guys. You just need to type this in on the calculator. Okay. Thank you. Now, what I wanted to show you, in the exam, there's a way to check your answer. I think some of you noticed last time that your calculator has an integrate button. Yeah? So let us check the answer here. Do some of you have this button? Yeah? So we're going from minus 2 to 1, bracket, alpha x plus 1 minus, bracket, alpha x squared plus 2 alpha x minus 1. Yeah? Did I type that in right? Yeah. The upper minus the lower. Okay. Let's see what we get. 9 over 2. So if this was an exam question, I would know for certain I've gotten it right, which is nice. Yeah? Okay, so there's just 2 more examples to do now. So for the next example, I just have to give you a special situation. What happens when the area is under the x-axis? Can I scroll down? Yeah. I'm sure some of you know this as well. So suppose we want this area here. Again, this is A and B. What's the area here? Or maybe you don't. Does anyone know what to do when the area is under? Yeah, but there's a small difference. Yeah, maybe.
You should.
The integral will be minus, so the way you correct that is by putting a minus in front of it.
Yeah.
So this is the formula if it's under. If the function is negative. Right. So in a situation like this, where you have an over and an under piece, you must split it into 2 problems. Okay? If we call this A, B, C, what would area 1 be? Integrate from
B and
A to B. Minus
B to C.
B to C. And then the total area? A1 plus A2, which would be the AB integration minus the BC integration. Okay? Let's have a look at an example like that. What type of function gives us this situation? Well, sine does, but an easier one. Like this. Cubic, okay. Right. Can I scroll down? Okay, one sec. Well, while some people are writing it down, you'll need the roots of this cubic. So while we're waiting a moment, give me the roots of this cubic. It's actually straightforward because there's no constant at the end. Yeah? Got the roots? What are the roots here? You missed a root. Yes. How did you get that? Without the calculator. Factorize, what do I take out? X. So x squared minus 3x plus 2. Right? And what does the quadratic become here? Minus 2 minus 1, isn't it? Yeah? So, what are the three roots? 0, 1, and 2. And I would like us to calculate this area. Okay? So, let's write the problem down. What's the first area here? Integrate from where to where? 0 to 1. X cubed minus 3x squared plus 2x dx. And next? Plus or minus, the next piece?
Plus minus. No.
Plus minus, also known as? Minus. 1 to 2. X cubed minus 3x squared plus 2x dx. Okay. Right, let us do this one. I suppose what's nice here is they're both the same function. I don't want to put the dotted lines. Okay, so what do we get? X 4 over 4 minus 3x cubed over 3. Yeah, so that just comes x cubed. And the next one? X squared. And the limits here are 0 and 1. Minus the same thing. And the limits here? 1 to 2. Okay, let's put in the 1. I think you just get 1 over 4, don't you?
Yes.
And let's put in the 0. You get 0. Oh, let's put in the 2. 2, 4, 8, 16. 4, is it? 4, 2, 4, 4 minus 8 plus 4 minus a quarter plus 1 minus 1. Are you giving me the final answer? That would be great. They cancel. Oh, they cancel too. Oh, this is wonderful. So we're just left with a quarter plus a quarter, also known as? Thank you. Right. Good stuff. Yeah. Right, I'm going to give you one last example here. And what is interesting about this example is that it was on, I believe, last year's Charles entry test for medicine. Yeah. But it could easily be an NCUK exam question as well. It's using the formula earlier for the area between two curves. Okay? So, I'll let you try this. If I write the question down here, find the area bound between y equals x squared minus x minus 6 and y equals minus x squared plus 5x plus 4. Now you could figure out which is the upper and which is the lower from a quick sketch. What shape is this? Concave or convex? The first one. Convex. And what shape is this? Concave. And if I want to make an area bound between the two of them, then you know the picture really has to be like this. So which is the upper one? The first or the second? Second. So it must be the area equals the second minus the first. And how do we find the limits? How do we find the limits? Yeah, substitution, simultaneous, yeah. Okay, I'll give you a minute to try this now. Give me the answer as a fraction. Now, what did you get for the two limits? Oh, sorry, did you not get the two limits yet? What were they? 5 and minus 2 and 5? Do you all agree? Yes, no? No, okay. Right, let's get the limits first. So what method should I use here? Yeah, x squared minus x minus 6 equals minus x squared plus 5x plus 4. 2x squared minus 6x minus 10. X squared minus 3x minus 5. 5 and 1? No. Oh, is it? It's bad, it's bad, it's bad. Okay. What are the two roots then?
3 minus root 29 over 2.
Nice.
And second one is
3 plus root 29 over 2. Can someone give that to me? Yeah? Oh, I don't know yet. Because I haven't typed it in the calculator. Are these the two roots?
the plus is 4.19.
Thank you. 4.19.
And minus 1.19.
19. Yeah? Pretty messy, huh? Right, let's put the lower one in. Minus 1.19. And the upper one? 4.19. Around about 52. If I put the two limits in. Now, why am I not bothering to actually go to the trouble of integrating and subbing in? Well, because the child's exam is an MCQ and they don't care for your work. So, you can just use the calculator, right? Because it's an MCQ, multiple choice. They're not going to know that you use the calculator to get the answer. Right? So, even though the numbers were very messy, it's straightforward. Right?
Correct.
Good. Okay. Let me give you some questions to try from the book now. Right, let's see. Let's say 1 21 23 and let me see another one here. No, they're three good ones. That's kind of easy, medium, and hard. They're three good ones. Yeah. Get started on those three there. Yeah? Yeah. Yeah. Because there's area between.
Which axis?
Which axis?
Yeah. Oh, you know, this equals 0.